All right, welcome. How's everybody doing? Good, excellent. So this is shipping a production web app in Elm. I'm Richard Feldman. And so people come to functional programming for lots of different reasons. In some cases, it's the beauty of it, the way you can express it mathematically. I come to functional programming because of this. I like to build things. I like to build big things. And even when I set out to build something small, often I find that it evolves into something big, something elaborate, something with a lot of nuance to it. And as I've done this over the years, I've had an experience over and over where I set out to build something like this. I end up with something like this. In short, I come to functional programming because I just want my code to stop breaking all the time. And I want to share with you an experience I've had with a particular piece of code. And essentially, this is a writing app that I built for myself back in 2011 in CoffeeScript. And what it was basically I had this experience where I had written about 80,000 words of a novel. And I said, you know what, I'm sick of doing this offline. There are better ways to do this. I'm going to put this into Google Docs. So I did, and then the tab crashed. And it turns out if you try to put an 80,000 word novel into Google Docs, or at least back then, it was not a good experience. The first thing that happened was I got the aw snap, and then eventually I figured out a way to get it to actually upload, and then it was like kind of go get a coffee, and it was really slow. So I tried some of the other alternatives out there, and eventually I was like, none of these are quite what I want. And I thought, you know, I'm a programmer. I'm going to scratch my own itch. I'm going to program my own solution. And this is it. This is actually not what I originally came up with. This is after several iterations. But I came up with a bunch of different things. I got like editing in the main area here. I can say editor and stuff. It syncs the outline for me over here. I can add a chapter. Hello, Lambda Jam. And scroll around, I got this cool like full screen distraction-free writing mode where it fades out the UI and I can just focus on the words and nothing else. And then when I want the UI back, click here and so forth. I've got a note system. I can create notes and search them. And everything all works offline. So I could write with it on an airplane. So that's all really cool. But I ran into this problem. And the problem, I think, really boiled down to the architecture that I chose to build this in. So the architecture I did was a sort of venerable front-end architecture, Gmoj, used all over the place, very popular. If you're not familiar with this term, this is a giant imperative mess of jQuery. Remains popular to this day. Basically, the symptoms of my problem were that paste broke. I couldn't paste things in my novel editing software, which is kind of undesirable when you're trying to write a novel. So I would go to paste something, copy would work, but I'd go to paste it, and then I get a runtime exception. I was like, oh, that's bad. Well, let me fix that. So I went in and I wrote a fix, and it was great, except that the fix broke something else. I was like, oh, all right, that's no good. Forget that. I'll go back and I'll revert that commit, and then go back to the world where paste is broken, and I'll just fix it a different way. So I did. But that broke a different thing. So eventually I was like, okay, you know what, I don't need that. I'll just work around this. I've built this in the browser, so I'll just go to inspect element when I need to copy and paste something, and I'll just copy the DOM elements and just cut them out and then move them to somewhere else in the DOM. And I was literally doing this while writing thousands of words in this thing. And eventually I had to have a self-intervention and say, self, this is no way to live. What are you doing? You need to rewrite this thing. You need to re-architect. Fortunately, between when I started building this and when I ended up at this point, which was, of course, after many, many iterations. What I just showed you was not the initial design. The reason it got that way was because I'd architected it this way, and I'd revised it. As I'd learned more about the use cases, I'd learned more about what I liked about the program, I'd revised the design. And the problem was just that the architecture didn't survive that redesigning process. It ended up with a giant mess where I couldn't maintain things. So I said, okay, cool. What have I learned in these intervening years that could let me do a better job next time when I'm rewriting it? And one of the most important ones was this talk, Simple Made Easy. This is a talk that I saw between when I started writing this and when I decided to rewrite it. If you haven't seen this talk, I highly recommend it. Rich Hickey absolutely changed the way I thought about programming. Really can't recommend it enough. And one of the things he talks about in this talk is this notion of simple. Simple being an objective notion. You can look at two things and say, this one is simpler than the other, or this is more complex than the other. It doesn't matter who you are. It's just an objective notion. He contrasts this with easy, which he defines as sort of near to your skill set. So something that's easy for you might be difficult for me, or vice versa. That's an important distinction to make because simplicity is something that you can just measure. You can compare two things and say, no matter who you are, this thing is simpler than this, or vice versa. But easy versus difficult is something that can change over time. So simple he defines as sort of the interleaving of concepts, or sort of the lack thereof. So if you have a large system, but each of the components can sort of be isolated, and you can just look at it and say, here's what's going on with this thing, and not have to worry about it impacting the rest of the components, that's a simple system, even if there are a lot of these components. In contrast, a complex system would be one where you have lots of interdependencies, lots of interleaving. Changing one thing, like hypothetically, just picking an example at random, if you were to try to fix paste and it were to break other parts of your system, that would be a complex system. You don't want that. It's problematic. But in contrast, something that's easy is, nearer to your current skill set. Importantly, familiarity can grow over time, but complexity is forever. So something that's difficult for me now can become easy just by my learning more things. But even if I learn more things, I can't make a complex system simpler just by learning. I can't just change myself and just make that become less complex. The only way to make it less complex is to change the code. But I actually can grow more familiar with things. Things that are currently difficult for me can become easier over time. An important distinction. Because simpler code is more maintainable. So that was really what I was looking for here. I sort of realized, based on his talk, that the problems I was having was because my code base was too complex. So I said, when I rewrite this, I want simplicity to be an explicit goal. I don't want to sacrifice features. I don't want to change the design. I like the design I've ended up with after all these iterations, but I want simpler code. So how do I get simpler code? So one of the tools that I learned, as I was going along, was this idea of stateless functions. So I was like, all right, I'm interested in this. What is a stateless function? AKA pure function, AKA referentially transparent function, whatever you want to call it. But the point is that these things minimize interleaving. And the way they do that is because they have this characteristic that whatever you pass in, whatever inputs you pass in, be they arguments or things in the enclosing scope, all the function does is look at its inputs and then return an output value. Just look at its inputs, return a value. It has no impact on the outside world. It doesn't have any side effects. And it doesn't read from the outside world. So what's important about those is that you can always consider them in isolation. You can just look at them and say, if I run this 20 times with the same inputs, it's always going to give me the same return value, and it's not going to do anything else. I was like, cool, that's interesting. Okay. So around this time, I said, all right, this sounds interesting. This sounds like it will make my life easier. It sounds like it will solve some of these problems I've been having. So why don't I just start using it more in the language I've already got, CoffeeScript. So I did. So I started writing CoffeeScript in a functional style. And actually, the first conference I ever spoke at was at the original Lambda Jam in Chicago, and I was talking about functional CoffeeScript because that's what I had started doing. And essentially, what I found was that this did improve things. It made life better. I stopped having as many of the problems as I was having before with things impacting other things unexpectedly. But the other thing that happened along the way was that React came out, and Flux came out with it. And so this sort of enabled me to write more of my code in this style. I could, instead of just using stateless functions for whatever portion of my code had to do with logic, I could actually start using it with the UI. That was really exciting to me. It's kind of like, all right, this is getting more and more interesting. The more and more of my code that I'm doing in this style, the better and better things are getting, the fewer and fewer bugs I'm having. So at this point, sort of the next logical question is, where can I go from here? How can I get more of this? And more specifically, what can I get that's sort of fundamentally better than what I'm doing right now? What I realized is that what I'd been doing so far was just discipline. I'm saying, okay, I can write functions with side effects, but I'm choosing not to. I can mutate state all over the place, but I'm choosing not to. The trouble is that discipline is hard and invariants are easy. It's difficult to do that on purpose all the time when you have access to other things because accidents happen. You make mistakes. If I didn't make mistakes, I probably wouldn't have had to go down this road at all in the first place. But the problem is that as programmers, we make mistakes. Sometimes you think you have a function that has no side effects, but if it's really easy to introduce them, you might accidentally introduce one. And then you have a bug later on where you're like, I don't understand how this is possible. How could this be happening? This function's stateless, or so I thought, but it turns out it actually wasn't. It turns out that you accidentally made some call that modified state or something that had a side effect, or maybe you were using a library which you assumed was stateless, but which in fact stopped being stateless, or maybe after an upgrade it stopped being stateless. It's hard, but invariants are easy. So I started saying to myself, okay, how can I get more invariants? How can I make my life even easier by making it easier to use this style that's brought simplicity to my code? Trouble is, over 200 languages compile to JavaScript, so I couldn't just say, oh, great, I'll use that one. That will make my life better. Okay, we're moving on. I had to sort of narrow down the field a lot. So I set out a set of criteria for myself, some deal breakers, some things that I knew were not going to be okay. One is just slow, bloated, compiled JavaScript. I care a lot about user experience, and in particular when I'm building something to use for myself. So something that's going to compile to bloated, slow JavaScript is problematic because that's a performance problem I can't optimize out. If I end up writing a large program and then I find, yeah, this is slow and I can't make it any faster, that's a huge deal for me because then essentially the only way to get the performance I want is to scrap it and start over. So that's no good. Another deal breaker, poor interoperability with JavaScript libraries. So one of the things that Dreamwriter uses is because it needs to work offline, everything needs to work in the browser, which includes the note system, which includes full text indexing. If you want full text search, like the feature, which I certainly do, you don't want to write that library yourself. There's a lot of work there. So I use lunar.js. So it's important that whatever language you're using is able to talk easily to JavaScript so that you can leverage this enormous ecosystem of libraries and not have to reinvent all these complicated things yourself. And then the third was that I didn't want something that was unlikely to develop a community. A lot of people create languages sort of in their spare time, just for fun, just to experiment, and I know that there's a danger that what you get really excited about right now might several months down the line become abandoned and not make any forward progress. So all of the things that you dislike about it or that are problematic are going to stay in that state, and perhaps even worse, you might discover that all of the code you wrote is just not worth keeping anymore and you need to throw it out for something else. Didn't want to go down any of those roads. Okay, so with those in mind, I sort of had two categories of languages that were left. One was just, this is JavaScript but less painful. So like Dart, TypeScript, CoffeeScript. So CoffeeScript is what I was already on, so that was already an option. It was just, okay, maybe this is as good as it gets. Maybe I stay with CoffeeScript. And then the other options were sort of less painful in various ways than JavaScript. But importantly, Dart and TypeScript didn't really offer anything that had to do with this idea of simplicity. They offered, sort of cleaner semantics in some cases, and they offered, type checking and things like that. But the pain points that I had to do with complexity versus simplicity. I wanted invariants around side effects and immutability, and neither of them really offered much in that department. So I looked further. Functional languages that easily talk to JavaScript, but are very different semantically. That's Elm, PureScript, and ClojureScript. Elm, at the time, I ruled out pretty much immediately because it seemed primarily to do with graphics and games. It had a lot of demos around that, but really not much to do with the types of HTML stuff that I was doing. This is an Elm talk, by the way, but we'll come back to that. Then there was PureScript, which had a lot in common with Haskell, obviously, and a lot of interesting semantics, and ClojureScript. So I sort of narrowed it down to PureScript and ClojureScript. Or, of course, there was the default case of just staying with CoffeeScript. So ClojureScript definitely had a flourishing community, great community. Clojure community is just a model programming community. Trivial JavaScript interop, you just call stuff and it works, very nice. But it allowed side effects and mutation. It had a lot of immutability, and the core APIs are designed, the core libraries are designed with immutable APIs, but you can still do mutation. You can still have side effects. So it's not an invariant. It just makes it easier to work in that style. So that had its appeal, but I was more interested in PureScript, which has 100% immutability, strong invariant. It has type inference, and type inference is something that sort of interested me. My path as a type versus dynamic programmer, I started off in typed languages, so C++, Java, actually Visual Basic, which was typed, any VB fans in the house. And then eventually I came across dynamic languages and found it was very liberating because I didn't have to be like, this is a string and this is an int. I'm like, I know what it is, just work. Of course, later on I found some drawbacks to that, but I do remember the pain of having to deal with this incredible verbosity and feeling like I had to hold the compiler's hand when I knew what I was doing. So type inference was appealing to me because it was like, oh, well, I can just write my code, normally. I don't have to be extremely verbose about it. I can only be verbose when I think it's warranted. And the compiler's still going to catch all my mistakes for me. It sounds like the best of both worlds. So I was interested in that, but I'd not really done anything serious with it yet. PureScript's Java interop, very straightforward. You just add a type signature. Write some JavaScript code, say I promise this is what its type is, and go from there. Functions cannot have side effects. I put an asterisk next to that because of the previous point, which is that technically you could write some JavaScript interop code and say I promise it has this type and lie. And it's going to type check and it's going to claim that it has no side effects, but in fact some side effects snuck in, which is less scary for me than it is from the perspective of using third-party libraries. I know that I would choose not to do that, but I was a little bit worried that somebody else might write a library that, oh, just, no big deal, we'll just sneak in a side effect here, nobody will notice, and then it would bite me somehow. But nevertheless, I was like, okay, we're doing this. We're going to rewrite in PureScript. This is going to happen. So as previously mentioned, at this point I was on React and Flux. So I was like, cool, let me go see what the PureScript React library is. Oh, there isn't one yet. There is today, but there wasn't at the time. So I was like, oh, okay. So I sort of followed some repositories and just sort of watched and sort of waited eagerly for someone to come out with one so that I could do another rewrite of Dreamwriter and embrace this fully invariant-based functional programming. And while I was waiting for that, a blog post came out. It was called Blazing Fast HTML in Elm. It's kind of like, interesting. That was that language that I wrote off because it didn't seem like it supported my use case. And specifically what this blog post was about was a new library for Elm that basically was like React and Flux, except with all the invariants I wanted. And the really cool part was this, a benchmark for To-Do MVC. So if you're not familiar with To-Do MVC, it's basically this sort of sample, simple app that demonstrates a lot of common UI paradigms where you just build a to-do list that the user can modify. And it's intended to be used for comparing different JavaScript frameworks, but it also works with different languages. So Elm not only implemented To-Do MVC using this new framework, but in fact benchmarked it against a bunch of others. And so some things that surprised me, one, despite using the same kind of style as React, it actually benchmarked faster than React. And two, it actually did better than Ohm, which is ClojureScript's library that wraps React but actually adds certain optimizations built in based on the fact that it knows it's working with immutable data structures and can check things faster. So the only library that did better than Elm is Mercury, which is sort of like the let's assume everything's immutable, but it's actually not immutable, so if you mutate something, you're on your own. Which didn't really sound like what I wanted. A little bit error-prone, perhaps. I don't know. I haven't used it, but it scared me off sufficiently. But I was really interested in this. It seemed like I could get all of the invariants I wanted and really good performance and write using the architecture that I want. What's not to like? So I said, okay, well, let's take a look at their JavaScript interop story. And the way Elm interacts with JavaScript is really interesting. I've never seen anything like this. It uses this system called ports, which basically treats your Elm code and your JavaScript code with sort of a client-server relationship where you're only allowed to talk between the two using immutable data, just raw data. You have this sort of pub-sub communication system. So to give the example, I had that little notes sidebar up in the upper right. It's this thing right up here, search notes. So when I type something into that, I'm using lunar.js to search the full text index of all your notes. So I'll type something in there and I'll say hamburger, and I want to get back all the notes that have the word hamburger in them. So I type it in, and Elm says, okay, great, there's that string, hamburger, I'm going to send that out through a port to JavaScript. I'm going to broadcast that. And then on the JavaScript side, I have some little JavaScript glue code that says, oh, I'm listening for events, got it, you got the string hamburger, you want to search for that. Go pass that off to Lunar, get the results, and then package those up again as just data, and send that back to Elm. Then Elm says, okay, got the search results, roger that. Now I'll render the search results in the UI. And the important distinction here is that at no point are we actually sharing code with JavaScript. So all of your Elm code respects all of Elm's invariants the whole time. And all of your JavaScript code is the Wild West that it usually is. But you don't have any mixing between the two. You don't have to worry about any of your invariants breaking in Elm as a result of stuff that happened in JavaScript. Really nice. Okay. So what do we have overall here? So we have 100% immutability. Great, that's what I wanted. We have 100% type inference. Great, also what I wanted. We have easy JS interop, but it actually preserves those invariants. There's no asterisk. Great. And functions have no side effects. All right. Then I found out about this, the time-traveling debugger. If you haven't seen this, I recommend going to the Elm website and checking it out. I don't have time to do a demo today, but it's awesome. It blew my mind, and it's like some Brett Victor stuff. Seriously, check it out, because it's really cool. Okay, so I was like, I'm sold. I got to try this. I'm doing it. I'm going to rewrite Dreamwriter in Elm. And I did. All of this, you can check it out at dreamwriter.co. This is Elm, and it's open source, so you can read the Elm code if you'd like. Okay. So, to do this, I had to go from my original architecture of giant imperative mess of jQuery all the way over to the goal architecture of purely functional Elm. Obviously, not quite a one-to-one mapping there. Fortunately, along the way, I had sort of an intermediate architecture, which was to take the original thing and just re-architect it without changing languages, just switch libraries and how I was doing my view code and organizing things. And then what that did is later on, when I was switching over to a purely functional style, and I no longer had access to mutating things in the middle of functions or having side effects in the middle of functions, it wasn't as big of a deal because most of my functions already respected that using discipline. So it was very important that I anticipated invariants while doing this, and I recommend that if you're going the same route, if you're going to be transitioning from something that's very imperative over to something that's purely functional, consider re-architecting it first with these invariants in mind. I think it's going to make the process a lot easier, because it certainly did for me. So let's look at a little bit of code here. This is some Elm code. This essentially renders some of the code on Dreamwriter. I've simplified things a little bit so that it fits on a slide, but basically, can everybody see that okay? All right. So this is not a template. This is not a special syntax of any sort. This is just plain vanilla Elm code. These are just Elm function calls. As it happens, Elm has a very nice syntax that is sort of conducive to DSLs, and this kind of reminds me of using things like Haml, where you sort of declaratively nest your DOM elements. So this thing up here, div, is just a function called div. It takes two arguments. The first is a list of attributes, which we put in square braces. And the second is a list of child elements, which also go in square braces. So that first set of square braces, we're saying, okay, great. We have a list of attributes. In this case, we just have a class attribute, but we could have put a bunch of others called sidebar. See later on, we have a span instead of a div, also just a function call, which has an ID of new note button, because it's the new note button, and I want to style that with CSS. And then it's got a click handler in there, on click, new note, and then empty value. We also see for the search notes, we have on input, search notes, target value. So a little bit more about what that does. So as previously mentioned, Elm doesn't have any side effects. So when you say on input and you're passing in values, what that's doing is not actually giving imperative handlers. So in JavaScript, you would say, you know, element dot add event listener input, and then an imperative function that would run every time that input was called. But in Elm, you do this declaratively. You say, okay, what I want you to do, what target value is doing there, is it's saying, okay, take event.target.value, which is the string the user typed in, so maybe hamburger in our previous example. And I want you to take that value, and I want you to wrap it up in something called search notes. And search notes is just a pure function, a stateless function, that's just going to return a description of what I want done, what I want, the way in which I want to update the UI based on what I got out of there. That's not going to be handled here. That's going to be handled in a different stateless function somewhere else, which is important because it means that this whole function, this entire render function, is entirely stateless. It's entirely cacheable as well. If I want to call it again with the same arguments, I can just skip doing that if I've already seen those arguments before. We'll come back to that later. So it looks pretty nice. It's pretty straightforward, pretty easy to use, and it's all just vanilla Elm code. Incidentally, if you're looking for the sort of before and after, I actually tagged the CoffeeScript version of this rewrite that used CoffeeScript and React and Flux, and then the Elm version when they were both at feature parity. So the Elm rewrite doesn't very closely resemble what I have now. I've obviously continued to improve on it and iterate on not only the code but also the design. But if you want to compare and see what it looks like to transition from one to the other when they're at feature parity, you can do so. So, how was it? How was the experience? It was so great. Oh man, this is like some of the most fun I've had writing code since I was like 10 years old doing Visual Basic, being like, I can make UIs. It was so excellent. I really cannot recommend it enough. The performance was just ridiculous. One of the best experiences I had was because, as previously mentioned, all of your view functions are stateless functions, and you really can just say, if I'm going to get in the same arguments, I don't need to bother running the whole function. I can just return the same value we got last time, and nothing bad will happen. That's true of like everything. So what that means is I had this experience where I was going in and I was actually modifying that search field, and I started typing in search, and it was slow. Like the characters were coming up slowly. And I was like, oh no, this is a bad performance problem to have, because my application had grown pretty large. And I knew that the problem was that it was having to re-render everything on every single time I put in a character. That's just sort of the normal React Flux style, is every time that you get an input from the user, you update your model, which reruns all of your view functions, and then diffs them and things like that to determine actual DOM updates on the screen. So I was like, oh, okay, well, I've done lots of performance optimizations. I'm not afraid to bust out the flame graphs and see what's going on. But first, why don't I just try, there's this little function called html.lazy, and then you just stick that in front of one of your view functions, and it just memoizes it. It says, if I'm going to get in the same arguments, don't bother calling this, just use the saved result we have. I was like, yeah, I'll try that. I'll put one here, put one here, put one here, put one here. Let's see what that does. Boom! Instantaneous. Like, no performance problem. Everything's just lightning fast suddenly. And I was like, what? I'm used to spending like days debugging performance problems. I can just sprinkle this around and it just works? What? What is this? Also, the package manager guarantees semantic versioning for every single package automatically. Like, let that sink in for a second. So what that means is that if a package author makes a breaking API change, they're not allowed to publish it. The package manager will reject it unless they bump the major version number. So you can actually rely on the versioning of your packages. And not only that, but when you're going to upgrade your packages, there's a diff tool. You can say what changed between 1.1.0 and 2.0.0. Just run that at the command line. You're thinking about upgrading, you want to know what changed. It'll just tell you what changed about the APIs. Say like, here's the new stuff, here's what stuff changed, and here's what stuff went away. Isn't that how it ought to work? Language usability. So this is in the most recent version of the compiler. There's been a push to say, look, why don't we make these type errors easier to read, right? Or easier to follow. It's great that the compiler tells you when you have a problem, but why can't it be more friendly? So check this out. I mean, it's just telling you, hey, here's the problem. Not all elements of this list are the same type of value. Lists have to be homogeneous. I noticed the mismatch here, and if you look at that little code sample there, it's got line numbers on the left, it's got the actual code that you wrote, and it even has a little squiggle under there, which if this were colored, you'd see it's a little red squiggle, like when you misspell something. It's like, oh yeah, it's right there, here's the problem. It's like doing as much work as it can to format the error message so that you can just look at it and be like, got it, I know where the problem is, and go fix it. Again, isn't that how it ought to work? Refactoring is just the most fun thing. Because I just keep having this experience where I'm like, okay, I want to change this thing, I'm going to change it. I just go through and just, all right, change it, change it, change it, change it, change it. All right, now I've got it how I want, and compiler, tell me everything I broke. Then I go and the compiler says, okay, you broke this, you broke that. Oh, right, go fix that. Hey, you forgot about this? Okay, cool. And then at the end, I bring it back up, and even without running a single test, it just works with no regressions. And I'm like, no, 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 that had to have broke. I just changed, I mean, here. This is a pull request I made to Dreamwriter that changed a few things, more than a few things. I guess there was like, okay, so this is a decent sized diff. Like, anyway, I'm just gonna keep doing this. So this was a change, and when I was done with this, I just compiled it and broke stuff and was like, let's see if it still works, and it did with no regressions. And this is normal. I actually expected that it was going to, which is crazy. Because I'm used to JavaScript where you get undefined is not a function when you break something, which is also something that I haven't had happen in Elm. I actually have not gotten any runtime exceptions yet, ever. It actually hasn't happened, just no runtime exceptions. Not only not undefined is not a function, my dearest friend, but none. And that's because Elm's type system and compiler are super great. They're just really well designed. I am aware that conceptually they exist. Certainly you can get a Stack Overflow, you can run out of resources. There's all sorts of ways that a runtime exception could happen. But in practice, just using the language, it's difficult. Like, it's so difficult that I haven't accidentally done it yet. Which, coming from JS land, is just phenomenal. So yeah, in short, it's been a great experience. And that lets me build things more like this and less like the falling over building. I can have this good experience, and I can still build these really nice things that actually stand the test of time. I think that's really because of all the languages I've ever used, Elm is the simplest. There's just not a lot going on to it. It's built out of these simple primitives, and they work really well together. Stateless functions and immutable data. That's it. No mess. So, in short, no runtime exceptions, semantic versioning guaranteed, time-traveling debugger, check it out, elmlang.org if you want to learn more. So then, the big question, would I like to ship another web app in Elm? Oh yeah. Thanks very much. One other note, that was not a hypothetical. I work at a company called NoRed Inc., and we've actually started using Elm in production. We have students answering 2.5 million questions a day. We're based in San Francisco, and we're totally hiring, so hit me up if you're interested in that. Thanks. Questions? Yes?
So is Elm a web DSL, or is it a general purpose language with?
It's technically general purpose, but it's heavily geared towards web right now. So the intention is to sort of focus on that use case. Technically, you can also, so it compiles to JavaScript. You can use it with Node, and actually Elm test, which is the test runner, is written using Elm bindings to Node, but it's like very on the back burner. It's not the focus right now. The focus is on making the experience of building stuff in the browser really great. And then in the future, there are long-term plans to compile to Node, actually to even write a garbage collector and compile straight to assembly, stuff like that, but it's way down the line, and I wouldn't expect it for a while. Yeah?
As a fellow cat guy, I love the cat pictures. I have two questions, actually. The first is, you mentioned that your choice of Elm over CoffeeScript was because of the library that CoffeeScript didn't have. As of today, what do you see as the relative advantages of each over the other, if there are? Secondly, what was the novel about?
And second, what was the second question?
What's your novel about?
What is my? Oh, the novel. Well, novel's out of scope. We'll chat afterwards. But so the first question was, so now PureScript does have a library like React for doing this stuff. What are my thoughts on Elm versus PureScript today? Basically, I think the answer is that if you like math and Haskell more, you will probably gravitate towards PureScript. If you're coming from a JavaScript perspective, you'll probably gravitate towards Elm. Elm has deliberately made some trade-offs to make things easier to get into and sort of like simplified the language at the expense of making things more mathematical and so forth. So yeah. All right. Thanks.